Trigonometric identities, quotient identities. Well, this is the third set of trigonometric identities which you should remember while proving the trigonometric identities themselves. So let's try to understand what quotient identities are. Okay, so let me make our standard triangle here to explain you what quotient identities are. Okay, so let's say this is our triangle in quadrant 1, okay, where the opposite side, let me write this by O as opposite side, A as adjacent, and hypotenuse as H, right? Okay, so, and this angle we are referring to is theta. Okay, theta is a Greek letter, and normally theta, phi, these are the angles alpha, beta, gamma, theta, right? These are the alphabets of Greek which are normally used in trigonometry. So let me put them here. These are alpha, beta, gamma, and theta. These are very commonly used alphabets, Greek alphabets, okay? If you like, you can use ABC if you want, okay? Like that also. But I prefer these Greek symbols. Let's get used to them, okay? Now, I will use this standard triangle in quadrant 1 to prove quotient identities, okay? So we are saying tan theta is sine theta over cos theta. Is it so? So let's start with the right hand side, okay? So in identities, that's what we do. We start from one side and prove that that side is equivalent to the other side. So in this case, let's start with the right hand side. So we say right side is sine theta. So right side is equals to sine theta over cos theta, correct? So I just copied this from here. Now, what is sine theta? So in this triangle, we see sine theta will be opposite over hypotenuse, correct? So we say opposite over hypotenuse, okay? Now this is my sine theta. How about cosine theta? Cosine theta is adjacent over hypotenuse. So it is adjacent over hypotenuse, correct? So this could be written as opposite over hypotenuse times, it is divide, so we'll make reciprocal of that. And then we write hypotenuse over adjacent, right? Now you can see very clearly that H and H cancel out, and so we are left with opposite over adjacent. Opposite over adjacent is what? Is tan theta, right? Is tan theta, which is our left side. Since right side equals to left side, we have proved our identity. So that is how you're going to prove trigonometric identities from now onwards, and there are about 100 examples to follow to make you an expert on this topic, okay? And I hope you'll enjoy this journey. So I've proved this one for you. Now let's go to the next one. Cotangent is cos over sine. Well, we could say cotangent is reciprocal of tangent, right? So 1 over tangent, so 1 over tangent will be cos over sine, right? We could do that. But let's go through the process once again, okay? So now this time we will start with, let me use another ink, okay? So, okay, that's fine. So we have cos theta over sine theta. So I'm starting with the right side, okay? So let's start with the right side now. Let me draw a line here to make this like this. Okay, that's fine. Now, right side. So right side is cos theta divided by sine theta. Cos theta is adjacent over hypotenuse. So I have here adjacent over hypotenuse divided by sine theta. Sine theta is opposite over hypotenuse. Opposite over hypotenuse. Well, this is what? This is cos over sine. So we're going from here to here, right? The right side. Now here I can write adjacent over hypotenuse times hypotenuse over opposite side. Is that okay? Now, H and H will cancel out. And you're left with what? You're left with A over O. Adjacent over opposite. So adjacent over opposite is cot theta, correct? So you're left with cot theta. So sine theta, cos theta over sine theta is cotangent theta, and sine theta over cos theta is tangent theta. So that is how you prove these identities. Okay, I hope you remember, and you have also learned a way that when you prove, you start from one side. So in this case, we started for right side and we came to the left side, and since left side equals to right side, the identity has been proven. Okay, so that is how you do it. Thank you.